Hello everyone. Today we're going to do a deep review on chapter 1 and chapter 2 by solving questions. The first question, we have an amplifier. The AV, which is the voltage gain, is minus 4.5. RL, which is the load resistance, it's 2 kilo ohm. VI, which is the input voltage, 3 volt peak. And the input current II is 0.25 milliampere. So this is the input current and this is the output current, right? And here we have a V output. Okay. The question also says that there's a current that draws 5.5 milliampere from each supply, which means that there's a current on each supply. What is the supply? We said that the power supplies are these, correct? So here we are having the current is 5.5 milliampere. The first part of the question says find the power gain in watt over watt and in dB. So the question has two parts. First we need to find it in watt over watt and then in dB. So how do we find the power gain? Power gain has two equations. The first equation is AV multiplied by AI. Okay, so AV is, we already know this, it's minus 4.5 from the question. AI is, we don't know it, we need to find it out. We have II, we need IO to find AI. So AI is I output divided by I input. I input is known, which is 0.25 milliampere. What's I output? We need to determine it where or how by Ohm's law. So I output is equal to V output divided by RL. What is V output? We do not have V output. How can we find it? We can find it through AV, which is the voltage gain. Voltage gain is V output over V input. So V output is equal to AV multiplied by V input. AV is minus 4.5. VI is 3. So the answer will be minus 13.5 volt. That's V output. We plug in the output in here. RL is 2 kilo ohm and you will get minus 6.75 milliampere. That's I output. After we have found I output, we can find I, the current gain. So the current gain is minus 6, sorry, I output is minus 6.75 milli, and so the current gain is minus 27 ampere over ampere. The answer is, the power gain is 121.5 watt over watt. After finding the power in watt over watt, we can find it in decibels. How can we find the power gain in decibels? It's 10 log A, the absolute value of AP. So the answer is 20.8 dB. Okay, now let's go back on finding power gain. We said that there are two ways for finding the power gain. What's the other way? The other way is it's V output multiplied by I output divided by V input multiplied by I input. But we need to be cautious here. There's a trick. We said whenever you use this equation, this is power, right? What's this? P output. What's this? It's P input. We said whenever using solving for P output or P input, we need to find the RMS only for sorry, and or P input. Okay, so now what's V output? V output is minus 13.5, but we need to do the RMS, so root 2 multiplied by I output, which is minus 6.75 milli divided by root 2 divided by V input, which is, what's V input? It's 3 divided by root 2, and I input is 0.25 milli. 0.25 milli divided by root 2 again, and this will give us 121.5 watt over watt, which is the exact same answer. Part B, the amplifier efficiency. The equation for efficiency is P load divided by PDC multiplied by 100. P load is, you can either find it by V output multiplied by I output, or V output squared over RL, or I output squared RL. Okay, in the previous question we already used this. Let's try this now. Okay, but you can just, for example, calculate this number and plug it in instead of PL. Okay, so we're going to solve it through the VO squared over RL. What's the output? The output is minus 13.5 in here. Okay, minus 13.5 squared, but don't forget that this is P output, P load, P output, so we need to do an RMS squared over RL. RL is 2 kilo, I guess, right? 2 kilo ohm, yep, 2 kilo. This will give us 45.5 milliwatt. Okay, now we need to find PDC. PDC is the power across the power supplies. We have two supplies, so it will be 15 multiplied by its current plus the other supply, which is again 15 multiplied by 5.5 milli. So 15 multiplied by 5.5 milli plus 15. You should not put minus 15 because the sum up will be 0 if you put a minus. So the answer is 110 milliwatt. Then 45.5 milli divided by 110 milli multiplied by 100 is 41.36%. Great. Part C, sketch the transfer function, and part D is sketch the waveform. Okay, so C, sketch the VTC transfer function, which is V output with respect to V input. Now, in order to draw a transfer function, you need to focus on two things: polarity of AV and the saturation limits. Why do I have to focus on the polarity of AV? Because it can either be this in this direction or in this direction, depending on the gain, V output and V input. You're dividing V, which is the slope. The gain is the slope. Okay, so now what's our gain? Our gain is minus, so our slope will be in the negative side. And then the second point in the saturation is the saturation limits. What's your saturation? 15 and minus 15. So here you're going to put two lines, and the limit is minus 15 and it's 15. What's V input? How can we find V input? We will say if V output is equal to 15 and if V output is equal to minus 15. Okay, so AV is equal to V output over V input. AV equal to V output over V input. We want VI, so it's V output over AV. V output is 15 divided by minus 4.5, which will give us minus 3.33 volt. Okay, same thing applies here. VI is V output over AV, so it will be minus 15 divided by minus 4.5. Minus and minus cancel each other out, so here it's 3.33 volt. So this manner we are done. Okay, let's do part D here on the side. Part D wants the waveform. Waveform is V output with respect to time. What is our V output? V output is minus 13.5 volt. First of all, it's minus, and it did not exceed 15. Hence, there is no saturation. So, we will start from the bottom. Let's change the color. We'll start from the bottom because it's minus and there's no saturation, so the peaks are minus 13.5 and 13.5. If there was saturation, then it has to be like this. For example, if this is the saturation limit, 15 and minus 15, then your answer will be like this. Okay, sorry, it won't be like that. It will saturate on 15 itself. No, let me give you another example. Let's say that the output was 17, okay, volt. Now 17 is greater than 15. So first of all, you have to draw it. Let's repeat everything again. Okay, so first of all, draw it normally. Time V output 17 minus 17. Now the expected output is 17 minus 17. However, it will saturate on 15. So here what you have to do is you have to crop it at 15. That's how it should be drawn. In case the output exceeded the input. Okay? That's only a side note. Next question. Okay, that's an amplifier. Whenever you have such question, you always have to do two things: connect the input and connect the output. Output is simple, it's always a load resistance, and on the input you either have to put a voltage source and a resistance or a current source and a resistance. Here you have voltage, hence it should be a voltage source and a resistance in series. RS source resistance and VS voltage source. Okay, so we are given these values: RI, RO, RS, open circuit voltage, which just means VS, RL, and it says if the output is 654.54 milli, find AV naught. Where's AV naught? AV naught is here. So first of all, we said we always start from V output. So you need the connection now between V output and AV naught. What can we do? It's obvious, voltage division. So we will say V output is equal to AV naught VI multiplied by RL plus RO. So AV naught is V naught divided by VI RL over RL plus RO. Now you just plug in the values. VO is 654.54 milli. VI is unknown because you have only VS, so we need to find VI from VS. So VI is VS multiplied by RI plus RS, which is again voltage division. What's VS? VS is 15 millivolt. RI is 15K plus 150K. Okay, so this will give you 1.36 millivolt, and then here it will be 1.36 milli multiplied by 200 over 200 plus 300, and the answer will be 553.471 volt over volt. Okay, so this is the answer. Next, another amplifier. So we have to connect input and output. Output is always load resistance. Input is either voltage source and resistance or current source and resistance. So here RS with VS. Okay, we need now an expression, no numbers. So Where do we start? We start from V output. We will say that V output is equal to, now we need V output, but we cannot do voltage division. It has to be a current division. So we have to start from I output. Okay? And what's the relationship between I output and V output? Ohm's law. So it will be I output RL. And then what's I output? Current division. GM V input R output over R output plus RL. Okay? Now what's V input? Because we need to arrive to VS. V input, we need to do voltage division, which is VS R input over R input plus RS. Taking this entire thing and plugging it in here will result in GM VS RI plus RS RO over RO plus RL. Then taking this entire thing and plugging it back in here will give us V output is equal to GM VS RI over RI plus RS multiplied by RO over RO plus RL, and don't forget to put RL, which is this. Okay, now we need V output over VS, so you have to take this down. So the answer will be GM RI over RI plus RS multiplied by RO over RO plus RL multiplied by RL. This is the final answer. Okay, it's simple. Next. Okay, now this is similar to the first question we solved, but it's vice versa. In the beginning we were given the circuit and we had to draw the sketch, the VTC. Now we were given the VTC, we have to extract information from it and find the given requirements. Okay, so what are we given here? We're given the current across the supplies. So let's do a sketch. We usually have V input in here. Okay, we have a resistance RL and we have the supplies. What's the current on the supplies? It's 0.3 ampere. Okay, what are the saturation limits? It's 10 and minus 10. How did I get these numbers? From the graph, from the sketch. Okay, now what's I input and I output? V input is 2.5. okay, RL is 150, I input is 7.5 milli. We're not given I output, no problem. We need to find efficiency. Efficiency, which is what? P load over PDC multiplied by 100. P load is V output squared over RL. What's V output? We do not have it. Let's find it out. Now, we can get V output from AV, correct? Because it's V output over V input and we have V input, but we do not have AV. But think about it. What's AV? AV is the slope. AV is the slope. So if you can find the slope, then you have AV. How can we find the slope? Simple mathematics. It's just 2 points. So for example, let's pick this point and this point. Okay? So AV, which is the slope, it will be y1 minus y2 or y2 minus y1 over x2 minus x1. Let's call this point 2, let's call this point 1. So y of 2 is minus 10, y of 1 is 10, x of 2 is 3.33, x of 1 is minus 3.33. This will give us minus 3 volts. So this is the slope. So AV is minus 3. V output is unknown. V input is 2.5. Hence V output is minus 7 0.5 volt. Okay, it's a bit tricky, but you need to just think about it and to become simple. We have to put root mean square because we're finding PL, and RL is 150. Yes, so PL is 187.5 milliwatt. Okay, now 187.5 milli. We need to find now BDC. BDC is 10 multiplied by 0.3 plus 10 multiplied by 0.3, which is equal to 6 watt divided by 6, and this will give, multiplied by 100, this will give us 3.125%. Okay, part B, we need to sketch the waveform. So here it's time with V output. What is V output? It's minus 7.5. Did it exceed saturation limit? No, so there's no cropping. And because it's minus, we have to start from the bottom. Hence, this is the waveform, and we are done. Okay, next. We have a high-pass RL filter. High-pass RL filter, which is sketched like this. This is a high-pass RL. Okay, we have the cutoff frequency R, L, and the question says find L. Now, always whenever they want R or L or C, just use the equation of the cutoff frequency. In this case, it's R over L. So L is R divided by omega C. R is 3 kilo. Omega C is 5.5 kilohertz. You need to convert it to 2 pi f. It has to be in radians per second. So the answer is 11 kilo pi rad per second. So it's 3k divided by 11 kilo pi. And this will give us L equal to 86.8 millihenry. Part B. We need the magnitude at the following frequencies, at 3 frequencies. Okay, so the first step is to find the magnitude. If you have memorized the magnitude, which I do not recommend, then that's fine. But in my case, I don't know what's the magnitude, so I have to recalculate it. So we start from the transfer function, H of S, which is V output over V input. V output is equal to voltage division. L becomes SL. So it will be V input multiplied by SL over SL plus R. Hence, H of S is equal to VO over V input, which is equal to SL over SL plus R. But don't forget to put it in the general form. What is the general equation? It's H of S, S over S plus omega C. So S has to be by itself, whereas here we have an L. We need to get rid of L. So we will multiply by 1 over L, and you will end up with S over S plus R over L. This is the transfer function. Then you have to break this into numerator and denominator. So this will become N1, N2, but of course after replacing S with H of JW. So it will become like this. Then N1 and N2. N1 is only JW, N2 is JW plus R over L. Okay, this is B1, A1 is 0, this is B2, and this is A2. So C1 is the square root of A1 squared plus A2 squared, as A plus b1 squared. I was right in the first place. So it will be 0 squared plus omega squared, and C2 will be omega squared plus r over L squared. So the magnitude is C1 over C2, which is omega squared, sorry, it's omega because they will cancel each other out here, okay, over square root of omega squared plus r over L squared. This is the magnitude. Now, after finding the magnitude, now you have to substitute in values of the frequencies. So at the first frequency, which is 1 kilohertz, it was 1 kilohertz, okay. What's omega? Omega is 2 pi f, hence it will be 2 kilo pi rad per second, okay. The magnitude is at 2 kilo pi is 2 kilo pi over square root 2 kilo pi squared plus r over L. R is 3k divided by 86.8 milli squared. Here it's 86.8 milli squared, which will equal to 0.178. That's the magnitude for the first frequency. For the second frequency, which is 5.5 kilohertz, the third one is 12 kilohertz, okay, you have to find W and then plug in. So the answer will be, you can solve it for yourself, 11 kilo pi. So the answer will be 0.707. Okay. For the third frequency, which we said is 12 kilohertz, okay, the magnitude will be 24 kilo pi. It will be 0.909. Okay, those are the three frequencies. What's the third part? If Vi is sinusoid with Vp 2.5 volt, draw the magnitude of the transfer function in dB versus frequency in hertz. So first you need to find the magnitudes in dB. The first magnitude in dB is 20 log 0.178, which is minus 14.99 dB. For the second one, which was 11 kilo pi, it's minus 3.01 dB, same thing, 20 log. Third one is J24 kilo pi, and it will be minus 0.82 dB. Okay, so now we have to plot the magnitude versus magnitude in terms of dB versus f in kilohertz. That's what the question instructed us to do. So how many frequencies do we have? We have three frequencies, 1, 5.5 and 12. Okay, now notice that all of your answers are in the negative, but you have to plot them in this area because it's a magnitude. Okay, so the solution is to bring up the zero line, so negative becomes here. Okay, so when we are in frequency 1 kilohertz, our magnitude in dB is minus 14.99. okay, so it's here. And For 5.5 it's minus 3.01, and 12 is minus 0.82. Okay, and this is our graph, and it looks like a high pass filter. Next, we have a series RLC band pass circuit. Okay, and we need to derive an expression for the magnitude. Let's start. A. Part A. So we have to start from h of s, which is the transfer function v output over v input. V output is equal to v input multiplied by r over r plus sl plus 1 over sc. Then h of s is equal to vo over v input multiplied by r over r plus sl plus 1 over sc. Okay, next we need to make it in the general form, which is h of s beta s over s squared plus beta s plus omega naught squared. So here in the numerator we should have an s, but we do not have an s, so let's multiply it by s. Okay, so it will become rs over rs plus s squared l plus 1 over c. Now what's the coefficient of s squared? It's 1, and here it's l, so we need to multiply it by 1 over l. Multiply by 1 over l to get rid of l that's accompanying s squared, sorry. So here it will become r over ls plus s squared plus 1 over lc, and this is the final transfer function, but we need to find the magnitude. First let's put it in the jw form, r over l jw over r over l jw plus jw squared plus 1 over lc, and this will become minus omega squared. Okay, n1 n2, n1 is r over l jw plus 0, n2 is minus omega squared plus, or let's put it in this other form. Would it fit? I doubt it. Anyway, for c1 it will be square root of 0 squared plus r over l w squared. So the answer is r over l w. That's c1. For c2, let's find n2. n2 is r over l jw minus omega squared plus 1 over lc. So c2 is square root of a squared. A is only this and this, so it will be 1 over lc minus omega squared all squared plus b. B is rl and w, rl and w squared. Okay, great. So now we found c1 and c2. That's c2. After finding c1 and c2, the magnitude will be c1 over c2, which is r over l w divided by the square root of 1 over lc minus omega squared all squared plus r over l omega squared again. Okay, that's the magnitude. Part B says we need to find the phase angle of the transfer function. Phase angle theta JW is theta 1 minus theta 2. Theta 1 is tan inverse of B1 over A1, which is tan inverse of B1. What's B1? This was B1 and this is A1. So it's R over L. W and A1 is 0. Hence it's tan inverse of infinity, which is 90 degrees. Theta 2 is the same, tan inverse of B2. What's B2? It's R over L with W, and A2 is 1 over LC minus omega squared. Okay? So now, phase angle is 90 degrees minus tan inverse of R over L omega divided by 1 over LC minus omega squared. Okay? Part C. Find R and L that yield a center frequency of 4 kilo and bandwidth of 10. So this is beta and this is omega naught, center frequency. And we have C. We need to find R and L. Part C. So how can we find R and L? We know that omega naught is equal to 1 over LC. Omega naught is, it was given in hertz, so we have to convert it to omega. It was 4K, so the answer is 8 kilopi rad per second. So 8 kilopi 1 over L. What is L? L is unknown and C is 10 micro, if you remember from the question. So the answer of L is 3.97 Henry. Okay, I think it will be millihenry. Double check this answer. Okay, I do not have a calculator right now. I have solved them before. So after finding L, we need to find R. We have a beta, right? R over L, correct? That's in bandpass. And beta was given, but it was given in hertz, so we have to convert it. So it's 2 pi 10k. Beta is 10k, correct? Yes. So the answer is 20 kilopi rad per second. 20 kilopi is equal to R unknown. L is 3.97 milli, which will give us R equal to 249.4 ohm. Okay? Now, next question. No, or is there part D? Yes, there's part D. Derive omega naught. We need to derive omega naught. Okay. Let's add another paper at page sorry, D. We need to derive omega naught. First of all, where do we get omega naught from? We get it from the magnitude, and the magnitude we just solved it, and it was R over L omega divided by square root of 1 over LC minus omega squared, entire thing squared, plus R over L omega again. Okay, we need to find omega naught, so we have to replace each omega with omega naught. So here we have to add omega naught. Okay, now let's draw the magnitude of the bandpass. That's the magnitude of the bandpass. Where's omega naught? Omega naught is in the middle here. At omega naught, what is the magnitude? It is 1, correct? So if we want to find omega naught, then the magnitude is 1. So this is 1 equal to the rest of the equation. 1 over LC minus omega naught squared entire thing squared plus r over L omega naught squared. Here I forgot a square. Okay, then you have to do what? Cross multiplication, 1 over LC minus omega naught squared plus r over L omega naught squared equal to r over L omega naught. Okay, and then we have to square both sides to get rid of the square root. So we'll end up with the following equal to r over L omega naught squared. Taking this to the other side will result in 1 over LC minus omega naught squared equal to r over L omega naught squared minus the same thing, so it will be 0. Squared equal to 0, and then square both sides to get rid of the square, so you will end up with omega naught squared equal to 0. So this will result in omega naught squared equal to 1 over LC. Taking the square root, omega naught is equal to square root of 1 over LC, or you can write it in this form. Same thing. So this is the answer. Okay? Great. This is a very long question. Next. This is an active bandpass filter, and the question says design. Design means find all the unknowns. What are the unknowns? R1, R2, R3, R4, R5, R6, C1, C2. Okay? Design. We were given the transfer function. It says amplifiers activated by 14 and minus 14, which means that there are sources here, 14 and minus 14. There are saturation limits. Okay? We were given R2, R4, R5, and we need to find the rest. Okay? Before we start analyzing the question, this is the low, this is the high filter, and this is the inverting. Okay? What is the general equation for active bandpass? It's H of S equal to beta S over S squared plus beta S plus omega naught squared, correct? Okay. So here, with the minus k, sorry, because it's active. Here we have a minus number and then S. Minus KB and S. So this number is equivalent to K with beta. What about this number? It's equivalent to what? It's equivalent to beta. And what about this number? It's omega naught squared. That's how you begin analyzing the question. So how can we find the gain? Look here. We have K beta equal to this long number 1570796, and beta is 314159. So if you plug in beta, you will end up K equal to, just divide these two numbers and it will be equal to 5. We found the gain. Now what can we do with the gain? We know that the gain is for the inverting, so it will be R6 divided by R5. K is R6 divided by R5. We know that R5 is 500, R6 is unknown, R4 is 8K, R2 is 100. Okay, and we need to find the others. So we need to find now R6. R6 is 5 multiplied by 500, which is 2.5 kilo ohm. This is the first requirement down. Okay, let's find the others. Now, what is omega C2? Because now we need to find R's and C's, right? We can find them from omega C1 and omega C2. Omega C1, is it for low or for high? and the same for omega C2. So here omega C1, it's coming with the high pass filter. So C1 is for R3 and C2, and omega C2 is with the low pass filter, so it's for C1 and R2. Okay, so omega C2 is 1 over RC, but which R and which C? It will be for the low, so it will be C1 and R2. C1 and R2. But do we have omega C2? No. How can we find it? Now we know from the lectures that beta in active bandpass, it's equal to omega C2. And beta we already know it's 314159. So omega C2 is known. 314159 equal to 1 over R2. Do we have R2? Yes, it's 100. And C1 is unknown, so you will end up with C1 equal to 31.8 nanofarad. We're done now with C1. Let's go and find C2 from omega C1. Omega C1 is 1 over RC, but which R and which C? It's R3 and C2. Okay, omega C1 is unknown, R3 is unknown, and C2 is unknown. But until now we haven't used omega naught squared. We know that omega naught squared is square root of omega C1. Sorry, we know that omega naught is omega C1 multiplied by omega C2. So if we want omega naught squared, it will be omega C1 multiplied by omega C2. What is omega naught squared? It's 98696,044. So it's 98696,044. Omega C1 is unknown. Omega C2 is 314159. So omega C1 is 314 rad per second. Rad per second. Okay, so this is omega C1. So here it's 314, but R3 is unknown and C2 is still unknown, so we cannot solve it. But let's think now. If gain is 5 and it's for inverting, what is the gain for the low and what is the gain for the high? It's a unity gain, right? The gain is 1. So we will say that K for high is 1 and K for low is also 1. But K for high, it's R4 over R3. It's R4 over R3. R4, K is 1, R4 is given, it's 8K, hence R3 is also 8K. So we found now R3. Same thing for low. It will be R2 over R1. R2 is 100, hence R1 is 100. So R1 is 100 ohm. We found R1 and R3. So R3 we said it's 8K. C2 is still unknown, hence C2 will equal to 0.4 microfarad. Okay, so by far we have found all the requirements for part A. Part B, it says find the magnitude of the transfer function at the center frequency at omega naught. What is the magnitude at omega naught? Let's figure it out. So we want the magnitude at omega naught. So in order to do this, or in order to solve it, you have to sketch the active bandpass. Where's omega naught? It's in the middle. what's the magnitude? It's K, right? It's the maximum. And what is K? K is 5. It's a tricky question, and it's very simple, by the way. So the answer is only 5. For part C, what is part C? It says if Vi is 4 volt, frequency omega naught, draw the output waveform. So we need to draw the output. But do you have the output? No. How can we find the output? Now, we know that the magnitude is V output over V input. So V output will be magnitude multiplied by V input, correct? But what is the magnitude? Magnitude depends on the frequency, and they want the magnitude at which frequency? Omega naught. And we have just calculated in the previous part that the magnitude at omega naught is 5. So here it will be 5 multiplied by the input, which is 4. So the answer is 20 volt. Okay? Now, we have to sketch the output. Now this is a very tricky sketch because there are 2 tricks in it. First of all, this number is 20, correct? Did it exceed the saturation limits? Yes, don't forget that he gave us 2 numbers for saturation, 14 and minus 14. So we have exceeded the saturation, so there will be cropping. That's the first trick, saturation. Second trick is that we have to invert the graph. Reason being, this is an active amplifier. Those amplifiers are reversing your sign. So if V input is 4, the output will be minus. If the output here signal is minus, which is the input here, so minus, it will be inverted to positive. If this is positive signal, it will be inverted again to a negative. Hence, your answer will be actually minus 20 rather than negative. Rather than 20. So first you have to start from the bottom. Okay, this is 20, our expected output. 20 and minus 20. And minus 20. Okay, but because of saturation, we will crop it to minus 14 and 14. Cropping, and this is the answer. It's a tricky, this graph is really tricky. Okay, next, low pass RL filter. We have cut frequency R and we need to find L. We said L can be found through the cutoff frequency equation. Okay, so it will be omega C equal to R over L. L is equal to omega R, which is 3K divided by omega C, which is 2 pi 5.5 kilo, correct? Yes. So this will end up with 86.8 millihenry. Part B, it says magnitude of the transfer function at the following frequencies: 1 kilohertz, okay, 5.5 and 15 and 12 kilohertz. Okay, as we have solved this question before, but it was for high pass. This is a low pass. Okay, so let's do it quickly. I will not derive it from scratch. I will just say that the magnitude, you know how to find the magnitude. It's equal to R over L squared plus omega squared, square rooted. Okay, we need to find it at 3 frequencies. So at F1 equal to 1 kilohertz, just plug in the value. So the magnitude will be 2 kilopi. It will be 0.98 at the second frequency. The magnitude will be 0.707 at the third frequency, 12 kilohertz, H24 kilopi. It will be 0.416. Okay, what's part C? Part C says if VI is 10 volt, what is this? There's a mistake here. 10 volt peak. Draw the output voltage waveform at those frequencies. So now we have to sketch V output. We need to sketch V output. How can we find V output at those three frequencies? V output is the magnitude multiplied by V input. V input is fixed. It's 10. V input is 10 fixed. But the magnitude depends on the frequency, correct? And we have three frequencies actually. So we have to find three values for V output at F1. So at F1, V output will be the magnitude, which is 0.98 multiplied by 10. So the answer is 9.8 volt. At F2, V output is 0.707 multiplied by 10, which is 7.07 volt. At F3, the output is equal to 0.416 multiplied by 10, so it will be 4.16 volt. Okay, now we have to sketch the outputs. The output with time. Okay, there's no saturation here, so it's just 9.8 with minus 9.8. Same thing for the other two graphs. Time, the output, time, and the output. Okay, the only difference is that the amplitude is changing, but here it's just a sketch. You will not notice this. 7.0, and you do not have to make it clear. It's just a sketch. Okay. (4.16) and minus 4.16. Okay, so we're done with this question. Next question. We have an active low pass filter. The question is find R2 and C, given that R1 is 3 kilo ohm. So the first thing to do is to write the general equation, minus K omega C over S plus omega C. Okay, so here we have K and omega C, and this number is K omega C, and this number is only omega C, right? Because it's independent, it's by itself. So how can we find K? If K omega C is equal to 17500 and omega C is 2500, then K is 17500 divided by 2500, which will equal to 7. That's our gain. Okay, after finding gain, we know that K is equal to the top resistance divided by the bottom resistance, so it will be R2 over R1. Here 7, R2 is unknown, R1 is 3K from the question, so R2 is 21 kilo ohm. After finding R2, we can find C. How can we find C? We know that K, we can find C from omega C, right? 1 over R2C, because it's the resistance and the capacitor together. Omega C is given, or is it given? Yes, it's 2500 from the question. So it's 2500, R2 is 21K, C is unknown, so let's find C, which will equal to 19.04 nanofarad. That's C. After finding R2 and C, let's move to part B. Part B says if Vi is 7, sketch the waveform of the output. If frequency of the input signal was 2.5 kilorad per second and 25 kilohertz. Now note here that there's a small trick. The first part is ready, it's given in rad per second. The second part is given in hertz, so you have to convert it to pi f. So this will end up with 50 kilo pi rad per second. So you need to find V output. V output is Vi multiplied by the magnitude, and the magnitude depends on the frequency. And you have two frequencies, so let's do it. We need another page. Now, this part can be solved using the, is it part B? Yes. Using the calculator, because you have numbers. So the only thing that you have to do is plug in the transfer function into the calculator. Our transfer function is, first we have to put it in JW plus 2500, correct? This is our transfer function. So you have to do it for two frequencies. The first frequency is 2.5 kilo J 2.5 kilo plus 2500, and for the second it's 50 kilo pi, which is equal to minus 17500 over J 50 kilo pi plus 2500. Okay, after doing that we have to go to the calculator. We will go to the complex mode 2. That's the first step. Then plug in the equation, plug it normally. Okay, third step, when you plug in the equation, press on equal button, then press on shift 2 with 3, shift 2 3, and then you will get the answer. You will get it in this form. It will be a number, then there will be a sign, and then a number. Okay, this number is the magnitude, this number is the phase angle. We need the magnitude only, so just take the number before this symbol. There will be a symbol like this. Okay, so when you do it in the calculator, here you will get magnitude equal to 4.95, and the magnitude here will be 0.11. After finding the magnitude, let's find the output, which is the magnitude 4.95 multiplied by V input, which is, what's V input? 7. Okay, the answer will be 34.65 volt, and for the second answer it will be multiplied by 7, so it's 0.77 volt. Okay, drawing the output, there's no saturation, but the output is inverted because this is an inverting amplifier. Whenever you see an inverting amplifier, you have to invert your output. So the graph will start from the bottom. Okay, the limit here is 0.7. This is just a sketch, Now the amplitude here has to be much smaller, but it's just a sketch. Here it's 34.65 minus 34.65. I am almost dying. Next, we have a series RLC bandpass. Find R and C that yields a center frequency of 5 kHz, bandwidth of 9 kHz, and use C equal to 10 microfarad. Okay, so omega naught, we know that it is 2 pi 5k, hence it's 10 kilo pi rad per second. Same for beta, it's 2 pi f beta, so it will be 2 pi 9k, hence it's 18 kilo pi rad per second. Then we know that omega naught is 1 over square root of LC. Omega naught is 10 kilo pi. Okay, L is unknown, but C is 10 micro, so you can find L and it will be 0.101 millihenry. After finding L, we can find R through the beta equation. Now in series, you have to take note, beta is R over L, but in parallel it's something else, right? It's 1 over RC. Anyway, so here it's 18 kilo pi, R is unknown, and L is 0.101 milli. R is equal to 5.7 ohm. That's it, we're done. Next, we're given this amplifier, so we have to connect the input and output. Output is always RL, input is always depends on this, right? So here, instead of current voltage source and a resistance in series, we have to put a resistance parallel with a current source. Okay, and we need to find Rm. Where's Rm? It's here. So let's do it. That's the output. The output is equal to voltage division. It's Rm II multiplied by RL over RL plus RO. And then we need to find II because we have all the numbers except II. So II is equal to current division IS multiplied by RS over RS plus RI. IS is 25 milli, RS is 150k, 150k plus 150 ohm. Hence the answer is 24.98 ampere, milliampere. Okay, so we need to find Rm, which is V output divided by I input, RL over RL plus RO. V naught is 700 milli. I input we just found 24.98 milli multiplied by RL. RL is 250. RL is 250 again, and RO is 300. Okay, so the answer here will be 61.64 V over A. V over A. Okay, that's Rm. Next, we're given, this is a silicon question. We need to find the whole current density, which is Jp of x. Now, the equation of Jp of x is minus q dp of x over dx, which is the derivative of an equation. If you notice here, we do not have an equation. It was not given to us. However, we were given a line graph of p of x. So you need to extract this equation. How do you extract it? Through the straight line equation, y equal to mx plus c. After you find this equation, derive it, and you can continue normally. So m is slope, we need y2 minus y1, 2 points, x2 minus x1. Okay, let's say this is point number 2 and this is point number 1. So y of 2 is p naught, y of 1 is 0, x of 2 is omega, and x of 1 is 0. So it will be p naught over omega. This is the slope, and the y-intercept is 0 because it's crossing the y-axis at 0. Hence, p of x is p naught over omega x plus 0, so it will be just p naught over wx. The derivative of p of x is only p naught over w. So this is the derivative. Let's go back in here. Q is 1.6 times 10 minus 19 to be memorized. dp is 12 and dp of x is p naught over w. P naught is 10 power of 15 and w is 3 times 10 minus 4. Okay, you need to make sure that all the numbers are in centimeter because he asked ampere over centimeter squared. So the answer is minus 6.4 ampere over centimeter squared. That's it. Okay, next. Okay, so here we have to find the whole current density at x equal to 0, but note here that we were given equation C for the whole current and the electron current. Let's begin part A. This is easy also. So Jp, it's minus q dp of x over ex. Q is minus 1.6 times 10 minus 19. dp is 12. Derivative of p is, let's derive it in here. It's p naught multiplied by minus 1 over lp e minus x over lp. Let's derive n in our way. So it will be minus 1 over 2 ln e minus x over 2 ln. Okay, so here it will be p naught. What's p naught? 10 power of 16 multiplied by 1 over lp minus 1 over lp. lp is 2 micrometer converted to centimeter. 1 meter is 100 centimeter. 2 micrometer is 2 times 10 minus 4 centimeter. Okay, so here 2 times 10 minus 4, and then e minus x. We said you have to substitute it in 0. So let's say here that we're finding jp 0 minus 0 over lp, which is 2 times 10 minus 4. Okay, the entire exponential will become 1. So the answer is 96 ampere over centimeter squared. That's for part A. For part B, the same thing, but for the electron current density, okay, with different numbers. So Jn x is equal to q dn, derivative of the n equation. Let's substitute n numbers. 1.6 times 10 minus 19. dn is 35. Here dn is 35. Okay, derivative of n is n naught, which is 10 power 14 multiplied by minus 1 over 2 ln. So minus 1 over 2 ln. What is ln? ln is 3 micrometer. Again converted, it will be 3 times 10 minus 4 centimeter. So 3 times 10 minus 4, and then multiplied by the exponential. E minus x is 0 over 2 ln. 0 over 2 sorry, 3 times 10 minus 4. Okay, the entire exponential will become 1. Let's close the square brackets. So the answer will be, here we're finding Jn equated at 0. So the answer is minus 0.93 ampere over centimeter squared. For part C, it says if the cross-sectional area is 150 micrometer square, find the total current. Now, total current, I total, can be found from A J total, right? And J total is Jn plus Jp. So our area, let's first fix the area. Area is in micrometer square, we need to convert it to centimeter square. So 1 meter is 100 centimeter, 1 meter square is 10,000 centimeter squared, hence 150 micrometer squared is, it's like this, 150 times 10 minus 12, because even the micro is squared, remember? So this will become 1.5 times 10 power of minus 6 centimeter squared. Correct? You have to multiply this number by 10,000. I think it's 1.5 times 10 minus 6. I don't really remember. Or maybe it's 150 times 10 minus 6. I do not have a calculator. Yeah, it's 150. I don't really remember. Just you calculate by yourself, okay? Just multiply this number. Sorry, just multiply this number by 10,000 and you will get it in centimeter square. Okay, it's 150 times 10, 12 minus 4, minus 12 plus 4, it's 8, correct? So 150, yeah, actually I was right. 1.5 times 10 minus 6, I was right. Anyway, so area, it's 1.5 times 10 minus 6 multiplied by JT, which is 96 plus minus 0.93, and this will give us 0.14 milliampere. This is the total current. Next, we need to find the resistivity. Resistivity for intrinsic silicon and N-type. Let's start with intrinsic. Rho is equal to 1 over Q P mu P plus N mu N. Okay, Q is 1.6 times 10 minus 19. P is equal to N naught. N intrinsic, which is 1.5 times 10 power of 10 centimeter minus 3, because it's at room temperature. Okay, so 1.5 times 10 minus 10, so it's 10, not minus 10, yeah, positive 10, multiplied by mu p. Mu p in intrinsic is 480 plus again 1.5 times 10 power of 10 multiplied by 1350, and this will give us this will give us 227,686 ohm dot centimeter. Okay, for part B, rho is equal to Q P mu P plus N mu N. Q is 1.6 times 10 minus 19. P N, because we're finding P in N type, it's Ni squared divided by Nd, so it will be 1.5 times 10 power of 10 squared divided by nd, which is 10 power 15. This will give us 225,000 centimeter minus 3, and nn is equal to nd, which is 10 power 15 centimeter minus 3. So here Pn and Nn, it's 22530 multiplied by mu P, which is 400, plus mu N, Nn, which is 10 power 15, multiplied by mu N, which is 1110, and this will give us 5.636 ohm dot centimeter. This is the answer. Okay. Next question. This is an active high pass filter. Okay. General equation for the active high pass filter is minus Ks over S squared plus omega C. Okay. Now note that this is the gain, it's ready, and this is omega C. Okay, so K is always equal to R2 over R1, top over bottom. K is 7, R2 is unknown, R1 is 2 kilo ohm, hence R2 is 14 kilo ohm. Okay, then we will say that omega C is equal to 1 over RC. It will be R1C. R1 is 2 kilo and omega C is 2500, hence C is equal to, which is the capacitor, it's equal to 2.22 times 10 minus 4, or if you want, let's say this 0.222 millifarad. Okay, that's for part A. Part B, we need to sketch the waveform at these two frequencies, and Vi is 9, so we have to multiply the magnitude with V input. Okay, part B. First, you have to do it using the calculator. So here it will be minus 7 j omega divided by j omega plus 2500 at f1, which is 2.5 kilo rad per second. Okay, you need to find the magnitude through the calculator. Okay, we just solved this question before, but it was for the active low pass. Anyway, after you find the magnitude, I will just write the answer. It's 4.95. Okay, and the output will be 4.95 multiplied by 9, which is 44.55 volt. For the second F, now it's 30 kilohertz, but you have to convert it to 2 pi F, so it will be 60 kilo pi rad per second. Anyway, so the magnitude will be 6.99, multiplying this with 9 will give us 62.91 volt. Okay. Let's draw now the output. Don't forget that it has to be inverted because it's an amplifier and there's no saturation, so it will be just like this. Okay, peak values, here it's 44.55 minus 44.55, 62.91 minus 62.91. That's it. Okay, what's the next question? Again, active band pass activated using 14 and minus 14. Design the band pass filter to provide an amplification of 5, which means K. Okay, with a band of frequencies omega C1, omega C2, omega C2, omega C1, and they are in hertz. Be careful. We were given R2, R4, and R5. You have to find the rest. So K is 5, and we know that K is R6 over R5. Okay, so R6 will be 5 multiplied by R5, which is 500, hence 2.5 kilo ohm. Okay, omega C1 is 2 pi F, hence it will be 100 by rad per second, and omega C1 is for high pass. This is high pass, so it will be R3 and C2. Omega C1 is 100 pi. R3 is unknown, but it's unity gain, so R3 and R4 are equal. So K for low is equal to R2 over R1, and K for high is equal to R4 over R3. 1 is equal to R2. What's R2? 100. R1, so R1 is 100 ohm, and R4 is 8K, so R3 is 8K again. Okay, now 1 over 8K multiplied by C2. C2 is equal to 397.8 nanofarad. That's C2. For C1, we can find it from omega C2, which is 1 over RC, R2C1. Omega C2 is 50K, so it will become 100K pi, and R2 is 100. R2 is 100, yes. C1 is unknown, so C1 is equal to I think I did a mistake here. Yeah, it ran out of power. Anyway, let's see, what did I do a mistake here? Low is C1 over R2. C1 R2, yes. So okay, C1, okay, no, I haven't done a mistake, it's correct. The answer is 3.18 microfarad. 3.18 microfarad. Okay, so I have found all the unknowns. Okay, part B, find the center frequency, which is omega naught. The center frequency, simple. We know that omega naught is square root of omega C1 multiplied by omega C2. .8 3.18 micro multiplied by 397.8 nano, and this will give us 9934.58 rad per second. For the third part, it says if Vi is 4 volt peak, frequency at omega naught, draw the output waveform. So we need to find V output, which is the magnitude at omega naught multiplied by V input. And you know that this is the what is this? No, this is the active band pass. This is omega naught, and the magnitude is K, and here K is 5. So 5 multiplied by V input, which is 4, and you will end up with 20. But don't forget that there are 2 tricks in this question. First is the saturation limits, and it should be inverted. So the answer is time V output. It has to start from the bottom. This is the expected output. 20 and minus 20. Here we have the saturation limits to be 14 and minus 14. Okay, next, same question but different slope. So we need to find JP of x, which is minus q, dp of x over dx. Okay, y is equal to mx plus c. Slope is y2 minus y1 over x2 minus x1. Let's say this is number 2, this is number 1. So y of point number 2 is p naught, y of point number 1 is 0, point of x2 is 0, point of x1 is omega, so it will be minus p naught over omega. C is p naught, so p of x is equal to minus p naught over omega x plus p naught. The derivative of p of x is only minus p naught over omega. Now let's plug in the numbers. Minus 1.6 times 10 minus 19. dp is 12. dp of x is minus p naught, which is 10 power of 16 over omega, which is 2.5 times 10 minus 4, and this will give us 76.8 ampere over centimeter squared. Don't forget the units. Next, we have a parallel RLC bandpass. Find R and L. We were given these numbers. Convert, because they are in hertz. Anyway, so here we know that beta is 1 over RC because it's what parallel RLC circuit. R is 1 over beta C, which is equal to 1 over 18 kilo pi. C is 10 micro, and this will give us 1.77 ohm. Okay, we also know that omega naught is 1 over square root of LC. We know that omega naught is 11 kilo pi. L is unknown, there's a square root here, and C is 10 micro. So after you play around with the equation, you will get that L is equal to 83.73 micro Henry. Okay, great. Too many questions, huh? Okay, I'm almost done now. So those are true false questions. You can read them by yourself. If you want, just take screenshots. I will not read them out. You can study them by yourself. They were discussed in chapter 1. Okay, I'll scroll now down. I hope you have took a screenshot. Okay, from question 7 to question 15. And then here we have one more true false question and some definitions. Screenshot. Okay, next, and then finally some advantages of active filters over the passive filters. Okay, I think I'm done for the review for chapter 1, chapter 2. I hope you have understood everything so far. Thank you.